Every second, millions of individual transactions, salaries, and localized trades are processed to measure the health of a country's economy. This raw data is synthesized into four primary macroeconomic indicators: gross domestic product, gross national product, net domestic product, and net national product. Public discourse often treats these terms interchangeably, assuming they all simply mean the economy. In reality, they are mathematically distinct tools designed to solve highly specific policy problems. Policymakers primarily rely on these metrics to answer two distinct questions. First, what is the true, pure national income generated by citizens? And second, how does the economic growth of one nation objectively compare to another? To find those answers, we have to subject these four indicators to a strict process of elimination. We need to build a conceptual matrix to filter them against precise economic constraints. Memorizing the underlying formulas is not enough to understand macroeconomics. You have to know how to logically eliminate the wrong metric for a specific policy question. Look at this blank 2x2 matrix. This is the framework we will use to map total economic output. We categorize the data by analyzing gross versus net on the y-axis and domestic versus national on the x-axis. The domestic variable strictly measures internal strength. It captures the monetary value of all goods and services produced within a country's physical geographic boundaries, regardless of who produces them. Because it focuses on local geography, an increase in a domestic metric tells us that localized job creation is expanding within those specific borders. The national variable tracks both internal and external strength. It measures production strictly by a country's residents, whether they are operating inside their home country or working abroad. By tracking resident output globally, the national variable reveals how heavily a country relies on foreign economies, or conversely, how dependent the rest of the world is on its citizens. Shifting to the y-axis, we convert a gross metric to a net metric by subtracting depreciation. Depreciation is the inevitable loss of value in physical assets and capital over time due to wear and tear. Minimizing wear and tear requires better technology and infrastructure. When a net metric increases over time, it indicates that a nation's research and development is successfully improving overall macroeconomic efficiency. Combining these variables gives us our four foundational indicators. This matrix represents the complete map of an economy's total output. Now we apply our policy filters. Our first policy challenge requires us to identify which metric provides the purest calculation of a country's true national income. We isolate the bottom right quadrant, net national product. NNP tracks the output of a nation's citizens worldwide, removing the constraint of physical borders. It then subtracts the capital degradation of depreciation. What remains is only the true, newly generated wealth created by residents. When calculated at base production costs rather than skewed market prices, this specific metric is termed NNP at factor cost. In macroeconomics, this holds the official title of national income. To translate this massive national figure into a measure of individual wealth, policymakers divide NNP at factor cost by the total population. The result is nominal per capita income. However, this figure contains a structural flaw. It ignores the invisible tax of inflation, which quietly erodes the actual buying power of that income. To correct this, economists subtract base year inflation from the nominal value, leaving us with real per capita income.
Real per capita income is the rigorously filtered metric required to determine an individual citizen's actual standard of living and purchasing power. Returning to the full matrix, we apply our second policy filter, identifying the mathematically sound choice for comparing economic growth across different countries. An international benchmark requires absolute objectivity. The calculation must be free of internally dictated government variables. This immediately presents a problem with depreciation. The rate at which an asset loses value isn't a universal mathematical constant. It is a subjective figure determined by the policies of individual national governments. Because country A might write off industrial wear and tear at 5%, while country B writes it off at 10%, any metric relying on depreciation becomes useless for an apples-to-apples international comparison. This lack of objectivity eliminates the entire net row of our matrix.
Net domestic product and net national product are disqualified. The purity that makes NNP perfect for domestic assessment is exactly what disqualifies it internationally. We are left with a final elimination bracket: gross domestic product versus gross national product. The intuitive assumption is that gross national product, a metric explicitly tracking a nation's citizens globally, would be the superior way to compare a nation's global standing. The math proves otherwise. GNP suffers from a structural flaw known as the dual citizenship paradox. If an individual holds passports for two different countries and produces $100 of value, both nations legitimately claim that $100 in their GNP calculations. This causes massive global double counting. Next, GNP relies on net factor income from abroad, or NFIA. This is the difference between what a country's citizens earn overseas and what foreigners earn domestically. Because NFIA calculations are strictly tied to foreign exchange rates, rapid currency fluctuations will cause a country's GNP to swing wildly. The metric shows volatility that has nothing to do with actual changes in the country's physical production. But GNP's third structural flaw is its most dangerous. It can mask a domestic economic contraction. Look at this comparison. GDP measures internal geographic production, so it is directly proportional to domestic employment. If production drops, local jobs drop. But imagine a scenario where local industries collapse and mass unemployment spikes. If at the exact same time overseas citizens send back a massive influx of foreign income, the total GNP figure will rise. The economy is shrinking, but the data displays growth. Because GNP can hide severe domestic unemployment behind foreign cash injections, global institutions reject it for cross-border benchmarking. They rely strictly on GDP to measure the localized, objective health of an economy. Bringing back our complete macroeconomic matrix, we have clear answers for our two policy challenges. When the objective is to isolate and calculate the true earnings of a nation's citizens without the distortion of capital wear and tear, policymakers must use net national product at factor cost. When global institutions need to objectively rank international economies, they isolate pure geographic production by using gross domestic product. GDP serves as the standard specifically because it filters out the mathematical distortions of subjective depreciation rates, foreign exchange volatility, and dual citizenship double counting. In macroeconomics, executing the calculation is only half the work. Knowing a metric's exact mathematical constraints is how you determine what the data is actually allowed to tell you.